So what I'm going to try to do is just give you an alternate scenario. I'm not going to do the problem that you have to do for today's lab assignment. But let's say this, that you went to a Dick's Sporting Goods, all right? And there was somebody at the door giving a survey. And that person said to you, are you between the ages of 25 and 35? Okay? And if you were, they gave you the survey. And if you were not, they did not give you the survey. And on the survey, it asks you what your favorite sport is. Okay? And so let's look at the various things at the start of this chapter that have to do with identifying specific statistically important concepts. So first of all, and folks, as you come in, if you could please, you know, mute your mics so that we don't hear everybody's mic, okay? Because I can definitely hear someone. So other than the person I'm talking to, who is Shelley, and everybody else can listen, of course, but please mute your mic. All right, so again, let me say, we're talking about a survey that's being given in front of Dick's Sporting Goods. And as you come in the door, the person says to you, are you between the ages of 25 and 35? If you say yes, then they give you a survey. If you say no, they don't give you a survey. And the only question you really have to answer on this survey is, what is your favorite sport? All right? So one concept is the population. The population that this guy is trying to reach are adults between 25 and 30. Okay, that's why he asked you that initial question about your age. Now, he's not asking you about your gender. He's not asking anything else, just your age. And on that one question, he's either giving you a survey or he's not. So the population he's interested in conducting the survey are adults between 25 and 35 years old. All right? Okay. But the sample is a different animal, right? Because a sample is a subset of a population. And the sample actually consists of adults at Dick's that day that answer the survey. I mean, because even if he hands you a survey, some of you are going to just put that in the first available trash can, right? And others are actually going to fill it out. Okay? So the other way of thinking of a sample is, what is the data? Well, the data is, in this case, a word, right? The word that describes your favorite sport. So the names of sports. That's what the data consists of, right? And of course, very few surveys would have exactly one question, but let's just play along and say that's got one question, all right? Now, later on, it asks you to determine what the level of measurement of this data is. And there are 4 levels of measurement, okay? And that is nominal, ordinal, interval, and finally ratio. Now, you ask a specific question at each one of these particular levels, and if you say yes to that question, then you move down to the next level. If you say no, then the data stops at that level of measurement, okay? So at the nominal level of measurement, what you ask is, can the data be placed in a meaningful order? Now, the key here is that a meaningful order must do something like ranking, okay? So names of sports, is there any order I can place those in? What do you think, Shelley?
No, I don't think so. I don't know.
You are correct. Of course, I'm trying to trick you into saying alphabetical order. Okay?
That's
alphabetical is yeah. Alphabetical is never a meaningful order because it doesn't rank. You know, basketball is not inherently better than soccer just because it starts with a B. Okay? So you say no to this in the case of names of sport, which means their level of measurement of this data is nominal. Okay? But as an aside, let me say that not all things that are simply words stop at a nominal level of measurement. What if I ask on a survey what your military rank was? You see, military rank is going to be a word, but you can place them in a meaningful order, right?
Right.
Or, for example, grades, right? So letter grade, the meaningful order I could put them in would look like that, right?
Mm-hmm.
So if you say yes to this question about meaningful order, you move up to ordinal, like you would with grades. And at ordinal, you ask, does the difference between two data pieces, hey, whoever doesn't have their mic muted, please mute your mic. The only two people who should have their mic not muted is me and Shelly right now. Okay, because we can hear a squeaking and this, that, and the other. Okay. Does the difference between any two data pieces have clear, universal meaning? So if you think about grades, it would be like asking, does the difference between an A and B, is it clear what exactly makes the difference between an A and a B? And I'm going to say that that is not true because it depends upon the grading scale of the instructor, doesn't it?
Right.
So grades stop there at ordinal. But what if we were talking about something like measuring temperatures? All right. So if you looked at temperatures, things like temperatures in a room might be 65 degrees Fahrenheit and 72 degrees Fahrenheit and 90 degrees Fahrenheit, like that. Now, this does have clear meaning between any two pieces, right? Because it's so many degrees Fahrenheit, and I understand what that means, and anybody who's familiar with Fahrenheit degrees knows that that's a very universal idea. Right? So temperatures would be able to be placed in a meaningful order. Here it's coolest to hottest. The difference between any two of them has clear universal meaning. So we say yes to both of those questions, and then that moves us up to interval. And at interval, we ask, does 0 mean either none or the beginning of the scale? So does 0 degrees Fahrenheit mean none? Or is it the beginning of the Fahrenheit scale?
Beginning?
No. Yeah, it's not the beginning, right? Because we have negative Fahrenheit degrees. Doesn't happen much around here very much, but you know, it can happen. Mm-hmm. So in fact, when measuring in degrees Fahrenheit, temperature stays at the interval level of measurement. Okay? But what about something like salaries? All right? Can I place, say I got 5 different people to tell me what their salary was. Can I place that data in a meaningful order? Sure. From lowest to highest or highest to lowest. Do the differences between any two of the salaries have clear universal meaning?
Yes.
Sure, because, you know, I mean, we know what a dollar is, and the difference between any two will be some dollar amount. So I say yes again, and it moves the interval. And does 0 really mean none in the case of salaries? Yes, it does.
Okay.
So then you move up to ratio, and that's the highest level of measurement. Okay, so I digressed a little there to explain level of measurement, okay? But you see where we're going with this. We're able to take and say a lot about the scenario here of the survey and what the data represents. Obviously, this data is also qualitative, right? Because it's names, okay? So qualitative data is a descriptor. And whenever it's a name, right, it's clearly going to be qualitative.
Okay.
But there are numbers that are also qualitative. Okay, so in this case, we look at a situation which is sort of like all beagles are dogs, but not all dogs are beagles. Okay? So there are things like social security numbers, which don't count you, right? They don't. They give information. So they are numbers, but they are also qualitative in nature. So we can say here some numbers will also be qualitative, like social security numbers, or for that matter, your P number for the college, right?
Mm-hmm.
Okay. If we looked at these temperatures, well, clearly that's quantitative data. All quantitative data is numbers, okay? But not all numbers are quantitative. You see what I'm saying? These are quantitative because they either count or measure. In the case of temperature, they measure. Didn't mean to put measurable. Okay. So for something to be quantitative, it has to either count or measure. Okay? So this kind of roughly is the stuff that's in the first task on your assignment for tonight. Does that make it any better?
Yes, I'm going to go back and look at it, and I think that I'll
Okay.
hopefully understand it a little better after that.
Okay, somebody here along the way will probably ask me about the sampling techniques, and when they do, we'll talk about that as well, because that's probably something that, you know, you want to ask about.
Yes.
Okay, the chapter also talked about sampling types, okay? And there's lots of different ways to take samples. In general, most of the errors in statistical analysis don't lie with the analysis, they lie with the actual original data set. Because the hardest thing in statistics is to take a good representative sample of adequate size. And something doesn't have to be a large size necessarily to be a good sample, but it does have to be representative of the underlying population. So a lot of the sampling techniques that they talk about in the chapter are not necessarily great ways of doing it. Should only be Ariel and I that have our microphones unmuted right now. I'm getting feedback from somebody's microphone. Okay, so the gold standard of sampling is to base whatever sample you do on the idea of randomness. And part of the chapter went into the definition of what a simple random sample is, and you should go back and look at that. But I want to point out that a description may include the word random without actually being a randomized sample. So you need to be careful about that. So here are the ones that they highlighted, okay? The first one they highlighted is a stratified sample. And in a stratified sample, the that doesn't look like the subjects are separated into groups Ariel, is that you that's moving things around? I really think
Yes.
there's, yeah, let's, everybody mute except Ariel and myself, okay?
It's probably me.
Okay, well, don't move things around. You're making me get a little feedback, okay? So the subjects are separated into groups at the direction of the experimenter. And it's important that you realize that it's at the direction of whoever's conducting the experiment. Because what happens is you use stratified sampling when you know that there will be a difference between, or there should be a difference between groups based upon some concept. So a good example is when you do a drug study, you almost always stratify the groups into men and women, so by gender, because physiologically the two genders are different. And what happens is that the actual effect of a drug on men may be very different from the effect of a drug on women. And you cannot, yeah, the feedback's driving me crazy, folks. You can't really look at the effects very clearly unless you separate the groups out in some way. I think the example that it gave in your book was about looking at separating different groups by income level, right? So what if I were to want to determine whether or not higher level students who have successfully completed more units in college read at a higher level, then it makes sense to stratify by class. So perhaps I have 4 different groups, a group of freshmen, a group of sophomores, a group of juniors, and a group of seniors. Do you see what I mean? But what they have in common is that the choice of separating the groups was done by the experimenter. That is different from cluster sampling. In cluster sampling, the groupings already exist. And you simply try to take and sample everyone in randomly selected clusters. So let me give you an example of that. Let's say that I work for a news organization, a local news organization, and I want to do voter exit polling. All right. Now, if I have 5 interns from the University of Tennessee, I cannot go and do exit polls at every precinct, right? There's no way I can do that. Therefore, what I would do is to randomly select 5 precincts and then send an intern to each one of those precincts with a survey for my exit poll, right? That's cluster because the precincts, they're the clusters and they already exist. I didn't have to create them by doing this thing that was done in the stratification. Clusters already exist. I take a random sample of the clusters and I try to talk to everybody inside those clusters. Okay? So another one that they talked about was called systematic. Systematic is where I apply some sort of rule, usually a mathematical rule, to separate into, to separate the subjects into groups. So, you know, that's something like, you know, occasionally you go in a store that gives every 1,000th customer a $5 gift certificate, right? That's a rule. I mean, you know, they are counting people. When they get to 1,000, they give a gift certificate and start over again. Or like on the playground in, you know, elementary school, where your teacher says, count off by 3s, 1, 2, 3, 1, 2, 3, 1, 2, 3, all the 2s go here, all the 3s go here. That is systematic sampling because some rule has been applied to separate the subjects into individual groups. Okay, very common is the use of what's called convenience sampling. And all that is I go get my sample through some mechanism that is easy for me as the experimenter. So like, let's say that I'm doing a project for a class and I want to know the attitude of my community towards Planned Parenthood, okay? And I think, well, you know, there are 150 people come to church every Sunday at my church. I'll just ask all of them, right? But you can see why that's not a very good way to do a sample, because it's easy for me, but I am fixing into that sampling technique a bias by only asking people at my church. They're very likely to be biased in some way. So it's a poor sampling technique, and yet it's a very commonly used sampling technique, because in many cases, people who give these surveys really aren't thinking about doing it in a statistically significant way. They are thinking about getting, let's say my pollster tells me I need 350 subjects. So I go and get it as easy as I can. I go down to the Kroger and hand out surveys, right? And when I have 400 of them in my box, I go away, right? But the problem with that is that not everyone in a community goes to Kroger. I mean, it seems like it some days when I'm there, but it's true that, in fact, they don't. And so I will inadvertently bias the results by only doing that, right? And if I'm there on, say, Senior Day, which of course I would be because I'm a senior, then I bias it further by shifting the weight towards seniors, because more seniors will be there on that day. So these were some of the sampling techniques that they talked about there. And you know, there are always questions about that on the test. I mean, everything that I've gone over here on this page is covered in one way or another on your all's test. So it's good to know. Ariel, did you get anything out of that? I hope you did. Okay, who knows? Ariel may be gone. Okay, so